Hi, and welcome to this video on sketching transformations of graphs. Now, the first thing is that you need to be really comfortable with, and it's not just a memory exercise, it's what all the different transformations are. Now, there's three categories, so 1, 2, 3, going from left to right. Now, the one on the left I call the stretchers, because there's two ways we can stretch. So I'm just going to write here, stretch in and stretch in again. And you've just got to know which one's the y-axis and which one's the x-axis. Now, I always go for look at the brackets first, because if there's something going on in the brackets, that tells you a lot about it. So I always say beware of the brackets. Now, can you see here the A is outside, and on the bottom one A is inside. So on this bottom one, when it's inside the bracket, can you see it looks like it's been multiplied by x? The brackets will always lie. What's actually happening here, it is a stretch in the x, but it's not, the x isn't being times by a, it's being divided by a. So, for example, if we have this, it means the x values are all going to be divided by 2, but the y's are staying the same. Which means this one must be the stretch in the y. When I see these, I think of like sine x and 2 sine x. Shocking graphs, I mean, I know, but when you put a 2 in front, it goes up, it stretches in that y direction there. So, for example, if we had 3 f of x, that means the x's, well, no change, but the y's are going to be times by 3. It's not in the bracket, so it always does exactly what it looks like. So they're the stretchers. Now we have the reflectors. Okay, so with this one, I always think of x squared and what happens when you put a minus in front. Well, it goes from happy to sad. So that must be, if you think from happy to sad, it's a reflection in the x-axis. So this is a reflection in the x-axis. So this one must be a reflection in the y-axis. And if you look again, there's no coefficient here other than 1, so when you see a minus on its own, it's a reflector. Actually, we could have a minus here, so we'll talk about that again in a bit more detail. So, but that tells me it's a reflector. It looks like it's reflected in the x. Beware of the brackets, they're always going to lie to you. It's actually reflection in the y. Okay, so this next one, let's start off with an example. So let's start with a plus, and let's put a -7, why not? So this looks like a y-intercept, doesn't it? On its own, the constant term on its own, and it pretty much is. This is a transformation of 2 up. This is a transformation of 7 down. Okay, it's not in a bracket. It doesn't, this part, it does what it looks like. Here, no problem. Here, it looks like it's times in by a. It was times in by a. Okay, so let's do a couple of examples here. Let's go +4. Now, hang on a minute. This is inside the bracket, so beware of the bracket. X is being added 4? No. It's having 4 taken away. It goes left 4. The X's, are they having 3 taken away? Nope. They're adding. Now that's quite a common skill really. Like if you were factorising, you had x minus 3 in one of your brackets, you'd write the solution to be x equals 3. Like the root values, and they're factorised. So they coincide. You've done this a lot up to this point, so it shouldn't be anything crazy for you. That's the easy bit. So we're going to have a look at some exponentials and some other like reciprocal graphs, and we'll see how we go. Right. So first of all, you need to know what this graph looks like, and that's pretty easy, especially when you think of what happens when x is 0. Anything to the power of 0 is 1. This can't ever be negative. You can't put any value in there and get negative, so it all has to be above the x-axis. If you put a minus value in here, like -2, you get a quarter, minus 3, 1/8, minus 5, 1 over 32. Really small numbers, and I think you can appreciate as this gets bigger, this gets really big really quickly. So actually what it looks like is that I was trying to hug the x-axis, but it's pretty difficult, and we said that was 1, yeah? Anything to the power of 0. So what's happening here? We've got this times 3. So if 2 to the x is the function, every time I see a 2 to the x, I can just write that. So I can see this is a stretch in the y, so all my y values are going to times by 3, but the x's aren't going to change. So that one is definitely going to be a 3 now. So I wanted it to come up a bit more like that. So just ignore this bit. So that's a 3. All my y values are times by 3. So I've got no numbers here, but they will all be 3 times higher. But the graph itself is going to look the same. Okay, so now I've got a minus f of x. I can see the minus in front is definitely a reflector. So it's now going to just look like that. So this is that same one as just before. Okay. Now this is a little bit more tricky. So I can't just write the function of x because there's that minus. So actually what I have is that. That is a reflector. Oh, is it a reflector in the x? No, it's in a bracket. It's a reflection in the y. So, I can't do it this way very well with a stylus. Sorry. That's meant to hug the x-axis, but that's still a 1. And we've got a bit more going on now. So we've got minus f of x, but be careful here. Can you see that 1 is superscript? It's not like here, is it? So that's with the x. So it's got to stay with the x. So this means we're going left 1, and we've also got a reflection in the x-axis. So, should I? Yeah, okay. I'm going to just start off with so imagine this one here on the left. This point is now going to be here. So this point's actually going to be there. So it's going to look like that. So that would be f of x plus 1. We can work out what this is. No problem, I'll show you how to in a minute. And now we have to reflect that. So it's actually going to look like that. You know, my drawings aren't great, but you try drawing it with a stylus on a screen. It's not easy. So if we put x to be 0 in here, we have 0 plus 1 is 1. 2 to the power of 1 is 2. And we have a minus in front of that. So that would be minus 2, and that would be a 2. Okay, so hopefully that's reassured you with some confidence. Let's have a look at another one. Oh no, we've got more. Sorry. I thought we'd finished, but we haven't. Same graph. Now, whoa. We've got 3 of the function of x. That's just 2 to the x minus 1. So we're going to bring this graph here on the left down 1. So the first thing I'm going to do is draw my asymptote here, and that is y equals minus 1. Now, we've got a stretch in the y, so all the y values are going to be times by 3 as well. So what it's going to look like is this would now be a 3. So actually what I've got to do first, if I do the stretch first, I have that, and all my y values are going to be times by 3. Now I'm going to bring this down, so it's going to tend towards this line here. So I'll go back to my purple. It's going to tend towards this line because it's coming down 1. Oh, no, I'm going to do that again because this has got to be a 2, so I probably should have drawn it a bit higher. Okay, that'll do. So that's a 2. Ideally, it's going to come up like this a bit more. Oh no, there's loads going on. So we've got this, we've got the minus in front. That minus 3 is with the x, and then this minus 1 is after. So we've got a reflection reflection in the x. Oh, beware of the brackets. Is x being take away 3? No, it's going right 3, and we're also then going to go down 1. The constant term on its own looks like a y-intercept. So I'm going to start off with the orange. So reflection of this one on the left is going to look like that. We're going to move everything right 3. So it's still going to, this point would be here, right? So it's going to cross much shorter here. So it's going to look something like that. So that point would coincide with this point here, if that's 3. And then we're going to move it down 1. So let's go back to our purple. So everything is going to come down 1. So it looks something like that. So we can work this out again. So let's put a 0 into this. So 2 to the power minus 3 is an eighth. So we've got minus 1/8. Take away another 1. Well, that's going to be what did I say? Minus 1/8. Take away 8 over 8 is minus 9 over 8. That's that value there. Okay. So I just want to say it again. So normally to do this I draw 3 separate graphs. I would never dream of doing that on one. I just draw 3 separate ones. I know some people like to go in for one, think about it. They make mistakes. Just do some sketches. Right, this is now a reciprocal graph, and from all your functions with domain and range, you should know x can never equal 0. And this is the worst graph to draw with a stylus. Okay, that's not bad. It actually looks like this, and you need to know that. Now I've got reflection, so just every time I see 1 over x, I just write f of x. So that's reflection. Oh, this is not easy to draw, so I'm sorry they look so bad, but that's not too bad actually. So that's that one. The same, so we've got the function, but this time we're going to add 2. So this asymptote I was trying to, it's going to move up, so that's y is 2. So this time it's going to do exactly the same as the one on the left. Oh, that's a bit wonky, but up 2. We've still got an asymptote here in the y, but on this one we've got 1, 2. Okay, let's try some more. So it's not as simple as just writing the function of x, because there's something attached to that x. So actually what this means, it's going to go left 1. So we're going to go on a little transformation left. So there's my asymptote from the 0 is now moving here, and my graph just does the same thing. Now what's happening here? With that's the same as saying 3 times 1 over x, so that is 3 lots the function of x. Now the asymptotes aren't going to move, and if you think about what's going to happen, before when we put a 1 in here, 1 divided by 1 is 1. Now when we put a 1 in, we're going to get 3. So if this is the original, if that's that same purple one, I'll draw it here as well. The new one is just going to be much higher. Okay, it's still going to tend towards, but much later. Okay, and that's it. So hopefully that's made a lot of sense, and you can go away and start practicing.